Hey, hey, hey.
What is
What?
up, everybody? Welcome to another Threat Thursday.
Yeah, hey, hey. Welcome, everybody. We are Sans Trey today. He is over at the RSA conference. It'll just be Jared and I for today's quick session. Today, we're going to talk about Azure enumeration, specifically how we're going to do that. This kind of scenario is predicated on an attacker getting on a box. They're doing some lay of the land, doing some enumeration on that box. They see that the user they have is signed in to Azure through the Azure CLI, and essentially they're just going to piggyback off of this already established connection. So essentially, they get on the box, look around, they see it, and now they're going to look around again, essentially restarting the kill chain of now performing enumeration and ultimately ideally, probably performing some lateral movement as well into the cloud environment. So should be a little different than our typical kind of one. Our detections are different. The test is a little different. But without too much further ado, Jared, over to you.
All right, thanks for that, Tyler. Yeah, so today's focus is on that kind of Azure enumeration. And this is something that we see often is that, there tends to be a lot of adversaries are going to try to pivot into a cloud environment. A lot of things are managed by cloud services nowadays. There could be a lot of things here in this cloud, in this site Azure, or in this Azure tenant, excuse me, that we would want as an adversary. So, like Tyler said, we're kind of coming from that assumed breach scenario here. This is an adversary that has landed on a machine, say someone in IT or a developer that has access to this Azure CLI. So, what the adversary does is in this type of scenario, once you've kind of pivoted into, say, a new domain, pivoted into cloud, the enumeration phase begins all over again, just to make sure that the adversary is able to continue onwards and onwards. So this is kind of what that's going to be. So we'll walk through the beginning here is once they're in the CLI, the adversary is going to want to figure out details about this Azure instance as best they can. So they're going to enumerate, get the subscription and tenant ID. And what this does, once you have the subscription ID and tenant ID, that unlocks some things you can do with the CLI now that you know exactly where you're at. So now that we know where we are, we go ahead and we're going to check and see that we are in this Azure cloud environment and we are Tyler Casey. So I have become Tyler now. And once we figured out who we are, we're going to go ahead and figure out what groups there are using the CLI. And then again, now that we know there's this AD test environment, we will be able to go here, enumerate further. And basically what you're doing is you're going to be, as an adversary, you're continuing onwards through kind of a chain here of enumeration. So once you find something from this response, you chain it into the next one and the next one. So you can go through the resources here.
Yeah, Jared, real quick, that's a really
Yeah,
good point.
this is
That
a good
was
one. Yeah.
we had done something similar to this in a PTE a few weeks ago, and it seems
Mm-hmm.
like there's like four really kind of base commands that you need to run for
Yes.
enumeration. You need to find out who you are, what the resource
Mm-hmm.
group is, any kind of IDs, and the subscription ID. So those are the first three commands that we ran there. Once you have those, you essentially are able to just fill in the gaps, or excuse me,
Mm-hmm.
fill in the variables like you're showing now, where now we're specifying what resource, what subscription, what user maybe. But you need those initial three or four commands to then continue on through the network. You can't continue on by just running like 15 commands all at once because you need that kind of additional information like you're showing here.
Right, exactly. So here's a good one. This one is listing VMs. We don't have VMs. We didn't have any VMs running. But for example, someone figures out that there's some VMs running. That's a little bit more information that can move them on because now they've kind of thought, okay, well, we know what VMs are here. We know what permissions we have. Let's see if we can maybe get onto a VM. Let's see if we can create one ourselves, for example. So we move on a little further here. You can see that it's enumerating through the storage account. And then it's finding, there's containers as well here. It's going to go through the storage blobs, figure out, hey, we have this blob here. And then finally, we can figure out some AD users as well. So now this expands, this is a list of people that we could fish. This is a list of people who we can try to get on their account, for example, like maybe this admin right here. So it's kind of getting that lay of the land all over again. And then let's say we identified this user, Tyler Casey again. We can go in and figure out everything that they have detail wise. You can see like mobile phone, email address, office location. If those things are in there, that is a treasure trove for an adversary, especially nowadays when we're seeing a lot of access is done through things like phishing. So now, not only do we have all of this information about this Azure tenant, you're also able to get contact information for people in IT. So we continue onwards here. We're also querying the app table. So this is all the app IDs within that tenant. And what you can do, for example, let's say you have an app ID related to Outlook. You can use that to query Outlook related services. Or if you have something related to Graph, you can use you can query Graph, for example. So once you're able to get that app list, you also have basically everything that's running that you're able to then continue further on and on.
Yeah, and the apps are a really great piece of enumeration, like you're pointing out here. The applications essentially will, or not essentially, will typically have some pretty elevated rights because they're like service accounts, or they're meant to perform certain actions. So like you had pointed out the Graph API app, that's actually the one that
Mhm.
we're looking at here. Your Graph API app, if you have Graph API access, you can essentially do anything, right? You can send messages, create users, enumerate SharePoint. The Graph API is extremely powerful. So if you're able to identify that this user now has access to, that the Tyler Casey
Mhm.
user has access to this application, you could see what permissions that application has, and then utilize the app in another form to then perform whatever
Yep.
actions you're trying to use.
Yeah, and I think actually Noah in the stream made a great point. Like working on living off the land in relation to AD. It's honestly something that the technique and the theory can kind of be expanded into everything because of the way systems are designed to be interconnected. So that's a really good thing to bring up, Noah. And then just, continuing for a little bit of the last, you can see that we are just going through and listing basically everything we can. So all these workspaces and everything as well. And then I believe this last one is policy definitions.
Yes. Yeah, the policies are super interesting because you have to actually download the policies to be able to read them. But what you can do, if you have access to these policies and you can view them, you can download them to your local machine, make the edits that you want. Like if you scroll all the way down to the bottom, I think the last one is called like allow my IP or something like that, which is just a test rule that we made just to showcase this. All the other
Yeah,
ones are
we've got a
built-in
billion
rules,
in here. Yeah.
but
Okay. Whoops.
um,
Yep, there it is.
yeah, the allow for my IP address. So let's say in this instance, you're only allowed to SSH from a few IP addresses as an attacker. It's not your IP address. You could download that rule, add your IP address to it, utilize some of this app information that you had also discovered, and then essentially be able to SSH
Mhm.
or log in from a different place than was originally intended. Um, but yeah, the main point of this one was to do some enumeration around what you're able to see, what's going on inside of the Azure environment and things like that. But this is really important as kind of the predicated actions that are
Mhm.
needed to then perform follow-on, more impactful actions. So in here, we talked about the policies. You can download the policy, modify it, re-upload it, or upload it. That way it'll modify the policy to fit whatever your kind of malicious needs for it are. We identified some of that blob storage and the containers. You can now that you know where things are. Let's say you found something really juicy. It wasn't just a PS1 script. It was credentials or credit card information or whatever it is. Maybe they're using it like a share drive. You can then download that. Now you know where that is. You can download it. So now you're able to exfil some information. That the users that are on there, this was a real environment. It would probably have their mobile phones, like Jared was pointing out, what department they were in, if they're an admin, maybe home address, things like that. So you could then try to now follow on and fish those people. If there's VMs on there, now the next step would logically, right, trying to laterally move to those virtual machines, or you can run commands through Azure onto the Windows VMs or the Linux VMs or whatever it is, to then allow again for lateral movement and just more visibility into their cloud environment. We're running to, I think, a lot more of hybrid environments where they have some on-prem
Hmm.
and some in the cloud. I feel like most everybody that we work with is running some kind of environment like that. So being able to see kind of both sides and expand your original footprint outside of just the endpoint, I think has become a lot more important in the last couple of years.
Yeah, I agree. And I think with that, that's everything in the test. So did you want to go over the detections real quick?
Yeah, I'll show our some of our detections that we have here. So this one again is a little bit different, or a lot bit different than what we normally kind of go over. I thought a good place to start would be just in the log activities itself inside of Azure. So these are just the default logs. This is just our test range that we use. We don't really use this for anything else. So we just have the default logs in there. Thing I thought was interesting is of all the commands that we ran, only two cause any kind of log at all, not even an alert, just an activity log that this thing happened. So the enumeration of the storage account keys, which makes sense because that's probably pretty important. And then the list classifies services, which is when we're listing out all of the applications. But other than that, nothing else is triggered at all. There's no even evidence of this activity happening inside of our logs in Azure. I thought that was pretty interesting. Definitely something to not take a look at, but definitely worth it to have some custom, maybe Azure discovery command rules in there or something like that to be able to identify more of this activity. Maybe if you're able to put some logic into it, like if you see 10 Azure discovery commands in a certain time frame or something like that to get an alert, but just out of the box, not really giving you much of anything. If this was a real environment and we had a ton of, like virtual machines and pieces like that in there, this would probably just get totally glossed over, right? Nothing super crazy here. That's happening. But over to Splunk, onto the actual endpoint logs itself. This was, oh, sorry, went to the wrong screen. There we go. Sorry about that. Um, thing, the logs were not what I expected them to be when we ran this. So we utilize our Scythe Azure module, which is written in Python to run these commands. So instead of just running like az.exe or something like that, we use the Scythe module to do it. And kind of just show you what I'm talking about here. So we'll see in the initial logs that we have a parent image of Python that's actually running from inside of the Microsoft SDK, that's that software development kit where the Azure CLI exists. So that's pretty interesting that it comes with its own Python executable. You don't already have to have Python installed. It comes with it for the Azure CLI, which essentially will call itself, right? We have Python calling Python, and it's telling it to run all of these enumeration commands, right? The account show, the storage account key list, and it's calling Python execute azure.cli. Once it does that, it also creates a telemetry log for each command that you run. So that's a pretty good point of maybe detection point. Something to monitor is Python executing outside of whatever your standard directory is. But this is pre-installed. It is a good, a known good thing that Python is in here. The telemetry is also probably a pretty interesting place that you could look at to see, that some kind of Azure activity is happening, but probably pretty atypical that stuff should be writing in there. The next one is then we see for the same commands, it essentially does it 3 times. So the second way is it runs command prompt. It runs command prompt because when it runs inside of the SDK, it's calling az.cmd, which is essentially just a command line wrapper. So it will call for command prompt, tells it to run cmd, which then calls Python, which then runs those commands. Kind of the same thing that we saw up above. And then the last way is actually how we're calling it from the implant itself. And we're going in a reverse order here. I'll show it in the correct order here on the next tab. We see that our implant is calling itself, right? That makes sense, which then calls command prompt, which then runs in a much more easy to view way the commands that are running, like AZ account list, account show, monitor log, et cetera, et cetera. The one thing on this that I do think is super interesting is even though it's calling the same command essentially 3 times, but it's never calling az.exe directly, which is the Azure CLI image. It's calling either that Python executable. You could see the az command, like az space whatever the command is. You could maybe make a detection off of that. Keyword detections for command line arguments are not super great, but something that you could do. But in this, I think it is very interesting and worth pointing out that it never calls az.exe directly. az.cmd exists and az.cl or azure.cli exists, but not az.exe, which kind of goes back to something we always point out in that if you have very simple detections, they can be easily bypassed, right? And what I mean by that is if your detections are looking for Azure activity on the endpoint and you're looking for just an image or parent image of az.exe, this will never trigger because it's not calling az.exe, it's calling az.cli or az.cmd. So just something to kind of point out there, that just having the one kind of detection to look for this activity could easily be bypassed by using a different module, a custom module, or now that you know that you can call Python directly inside of this SDK directory, you could then just call it exactly, or excuse me, you could call it implicitly from there, and bypass az.exe completely. So just something to be aware of, that there's more than one spot where this can execute from. Even though probably running just like az star is probably not a super good detection, because I would imagine that quite a bit would come from that. But so we saw it grouped. To put it kind of in the order, this will make a little bit more sense. So we have these 3 commands here are all grouped. It's all doing the same thing, right? So we're doing az account show, account show, account show, and account show. So how the actual kind of telemetry is running, or the order of how it's running, I know it has this one first just because it doesn't have the millisecond on there, or closer than, yeah, it doesn't have the millisecond on there, but it's going to run that az test, which is our scythe implant. From there, it's going to essentially a command line wrapper again, which calls CMD, which then tells it to run the az account show command. So you see CMD, and then our parent image here is then called. So the implant and then CMD, it tells it the same thing it was told here, which then triggers Python. Python runs that Azure CLI account show. That Azure CLI triggers here down below, which then again calls Python to run it, which runs the command and then writes to that telemetry log. So there are multiple places that you can identify this activity in the logs, but they're all pretty atypical, right? Again, the not calling az.exe, Python is running from a place that most people probably don't know exists. And so while it does generate more logs than I had thought it was going to generate in the beginning before we had gone over this, it's still a bit obscure. It's still a bit abnormal. And none of this activity, other than the listing of those account keys and the classifying of services, is listed in your Azure logs at all. So definitely something to be aware of, something to be on the lookout for. Again, as you see, more and more places have hybrid type scenarios of on-prem and in the cloud, especially with Azure. There's a ton of Microsoft shops out there that host a lot of their services. Someone running these commands, these enumeration commands in this volume, is almost definitely a predicate to running some now impactful commands in your cloud environment, probably looking for, again, exfiltration, lateral movement, account creation, policy modifications, things like that. So with that, went on a little longer than I thought I was going to. Yeah, with that, Jared, do you have anything else you wanted to add?
No, I think you summed it up really well.
All right, awesome. Well, thanks everybody for hopping on. We'll cut this just over the 20-minute mark. Thanks everyone for hopping on, and hope to see you next time.
Thanks for joining, everyone. Bye.